What if I told you that the biggest disruption in human history isn't happening in a smartphone or a chip lab? It's happening on the open highway right now, inside an 80,000-pound truck that doesn't burn a single drop of diesel. Tesla has officially started mass producing the Tesla Semi, and I don't mean a pilot run of 20 trucks for a press event. I mean full industrial scale production at the Nevada Gigafactory. Trucks rolling off the line every single day, heading to some of the biggest freight companies in the world. This is not a concept anymore. This is not a prototype. This is real, and it changes everything we know about freight, transportation, and energy. So today, let's break down exactly what happened, what this truck can actually do, who's betting billions on it, and why Elon Musk might be right that this changes freight forever. To understand why the Tesla Semi matters so much, you first have to understand the industry it's trying to fix. Trucking is the invisible backbone of the entire global economy. In the United States alone, about 72% of all freight by weight is moved by truck. Grocery stores, hospitals, Amazon warehouses, clothing brands, everything they stock arrives on a truck. There are roughly 3.5 million truck drivers in America alone, and the industry generates over $900 billion in revenue every single year. But here's the dark side of that number. The transportation sector is the single largest source of greenhouse gas emissions in the United States. And heavy-duty trucks, the big ones, the Class 8 semis, they punch way above their weight when it comes to pollution. They make up about 5% of registered vehicles, but produce nearly 25% of all transportation emissions. And it's not just the environment. Think about fuel costs. Diesel prices are unpredictable. In 2022, when fuel prices spiked, freight companies lost millions. Not because business was slow, but because every mile was costing them more than they planned. Driver shortages are another massive issue. The industry is short over 80,000 drivers right now, and that number is expected to double by the end of the decade. So the trucking industry desperately needs a solution, and to its energy costs, its emissions, and its reliability. That's the vacuum Tesla decided to fill. Let's go back to November 2017. Elon Musk walks on stage in Hawthorne, California, and unveils the Tesla Semi. The crowd goes absolutely wild. It looked like something out of a sci-fi film. Sleek, futuristic, with a cab-forward design that put the driver right at the center, surrounded by two touchscreens. No diesel engine, no traditional gearbox, just electric motors. Musk made some bold promises that night. 500 miles of range on a single charge, 0 to 60 miles per hour in 20 seconds with a full load. Operating costs 20% lower than diesel, and a megawatt charger that could add 400 miles in just 30 minutes. The industry was skeptical. Truck manufacturers laughed. Many analysts called it impossible. You can't run a Class 8 truck on batteries. Too heavy, too expensive, not enough range. That was the consensus. Then came the delays. Tesla originally promised Semi deliveries would start in 2019. That didn't happen. Then 2020 didn't happen. The pandemic hit, supply chains broke down, and the Semi kept getting pushed back. Critics use this as ammunition, proof they said that Musk's promises were just marketing, not engineering. Then December 2022 happened. Quietly, without a massive launch event, Tesla handed over the first production Tesla Semis to PepsiCo at their Sparks, Nevada facility. Real trucks, real deliveries, and everything changed. So what exactly does mass production mean, and why is it the game changer everyone is talking about? Building a prototype is one thing. Building a few hundred trucks for a pilot program is another. But mass production means Tesla has solved the hardest problem in manufacturing: scale. It means the factory line is running consistently. It means they figured out how to source the battery cells, assemble the drivetrain, and ship completed trucks on a schedule. At the Nevada Gigafactory, specifically the section now called Giga Nevada, Tesla has dedicated an entire manufacturing wing to the Semi. The factory uses a high level of automation. The battery packs used in the Semi are some of the largest ever put into a production vehicle, and assembling them at scale required entirely new tooling and engineering processes. The Semi runs on Tesla's 4680 battery cells, the same next generation cells being used in the Cybertruck and Model Y. These cells are larger, store more energy, and are cheaper to produce per kilowatt hour than older battery formats. Getting them into full production was one of the biggest bottlenecks Tesla faced. Once that problem was cracked, the Semi could scale. Reports indicate Tesla is currently producing hundreds of Semis per quarter, with plans to ramp up significantly. Analysts who track Tesla's factory output believe production could reach several thousand units per year by late 2025 or 2026. That's not Tesla's endgame. It's just the beginning of the ramp. Now let's get into the actual truck, because the engineering here is genuinely fascinating. The Tesla Semi has not one, not two, but three independent electric motors, one on the front axle for stability and traction, and two driving the rear axle for power. Each motor independently controls torque. This means the truck can manage wheel slip, cornering, and load balance in real time in ways a diesel truck with a mechanical drivetrain simply cannot. The range. Tesla claims over 500 miles on a full charge under real-world conditions. Independent tests done by PepsiCo drivers confirmed that semis running California routes were hitting 400 to 500 miles per charge consistently, even with full loads. For most freight routes in North America, which average around 250 miles per trip, that's more than enough range. Now let's talk charging, because this was always the biggest question mark. Tesla built what's called megawatt charging, or MCS. At a megawatt charger, the Semi can add roughly 70 miles of range per minute. That means in the 30 minutes a driver would typically stop for a federally mandated rest break. The truck recharges enough range to complete another full delivery leg. That's not a compromise, that's a solution. The aerodynamics deserve a mention too. The cab forward design and the dramatically sloped nose give the Tesla Semi a drag coefficient of around 0.36, significantly lower than a conventional semi-truck, which typically sits between 0.65 and 0.70. Lower drag means less energy needed to maintain highway speed. That directly translates into extended range and lower operating costs. Inside the cab, the driver sits in the center, Formula 1 style. There are two large touchscreens flanking the steering yoke, displaying navigation, vehicle data, and camera feeds. The ride is quieter, the visibility is better, and the regenerative braking system means the brake pads last far longer than in diesel trucks, saving on maintenance costs. Here's what separates the Tesla Semi from every other electric truck on paper. It has real-world data behind it now, and the data is genuinely impressive. PepsiCo has been the most public about their experience. They received 21 trucks in the first delivery wave and put them immediately to work on California routes, moving beverages between facilities and to distribution centers. Their drivers reported that the trucks were quieter, smoother, and less fatiguing on long runs. The acceleration, even with a full 80,000-pound gross vehicle weight, felt more confident than diesel at highway speeds. On fuel costs, PepsiCo estimated that they were spending roughly 60 to 70% less per mile on energy compared to diesel, depending on local electricity rates and route conditions. That's a massive operating advantage. For a company running hundreds of trucks, that saving compounds into tens of millions of dollars per year. Maintenance savings are another factor people underestimate. Electric drivetrains have dramatically fewer moving parts than a diesel engine. No oil changes, no transmission fluid, fewer brake pad replacements thanks to regenerative braking. Fleet operators estimate that electric heavy trucks could cut maintenance costs by 30 to 40% over the vehicle's lifetime. One challenge that's come up is charging infrastructure at scale. When you're running 20 trucks out of a single depot, you need serious electrical capacity. Tesla has been working directly with fleet customers to install megawatt chargers on site, but scaling that infrastructure is an ongoing process. Not a solved problem yet. PepsiCo was just the opening act. The list of companies that have ordered Tesla Semis reads like the Fortune 500 attendance list. Walmart has placed orders for 130 Semis. They want to use them for grocery and general merchandise distribution across their US network. Amazon is in for 100 trucks as part of their broader commitment to electrify their delivery fleet by 2030. UPS has reserved units. Cisco, one of the largest food distributors in the country, has also placed orders. DHL, FedEx, and JB Hunt Transportation are all watching closely and have either ordered or committed to pilots. These are not small companies making a green PR play. These are hard-nosed logistics corporations that run on thin margins. When Walmart or Amazon orders electric trucks, it's because their operations teams have run the numbers and the numbers make sense. Operating cost, reliability, and total cost of ownership, not just the feel-good factor, are driving these decisions. There's also a regulatory tailwind pushing this forward. California, which sets the standard for emissions rules that often spread nationally, has mandated that by 2036, all new heavy-duty trucks sold in the state must be zero emission. That's not a suggestion, that's law. Freight companies operating in California California have to make this transition. Tesla just happens to be the company with a product ready to go. Let's zoom out for a second, because the Tesla Semi is more than just a truck. It's a proof of concept for what's possible when you apply modern technology to industries that haven't fundamentally changed in decades. If the electric trucking transition scales the way current projections suggest, and that's a big if, but the trajectory is real. We're looking at a reduction of hundreds of millions of tons of CO2 emissions per year from freight alone. That's not climate propaganda. That's simple math applied to how many trucks are on the road and what they currently emit. It also changes the geopolitics of energy. Right now, diesel prices are tied to global oil markets, meaning freight costs in America fluctuate based on decisions made in OPEC boardrooms. Electric freight powered by domestically generated electricity breaks that dependency. It's an energy security argument as much as it's an environmental one. And think about the grid implications. Millions of electric trucks plugging in every night create a massive new demand on the power grid. But they also create an opportunity. Smart charging can shift demand to off-peak hours when electricity is cheapest and most abundant. In the future, truck batteries could even feed power back to the grid during high-demand periods. A concept called vehicle-to-grid, or V2G. Freight fleets could become mobile power storage networks. This is the vision Elon Musk laid out. Not just selling trucks, but reshaping how energy flows through the entire economy. Now, I want to be honest with you, because not everything is smooth road ahead. The charging infrastructure gap is real. For long-haul routes that cross multiple states, there simply aren't enough megawatt chargers yet. Building that network takes time and billions of dollars. Until it exists, the Tesla Semi's range advantage doesn't matter much if drivers can't reliably recharge mid-route. The upfront cost is significantly higher than a diesel truck. A new diesel Semi runs between $150,000 and $200,000. A Tesla Semi is estimated to cost in the range of $250,000 or more depending on configuration. For small freight operators, the mom and pop trucking companies that make up a huge portion of the market, that's a barrier that financing alone can't always solve. There's also the question of cold weather performance. Batteries lose efficiency in extreme cold. For freight operations in Minnesota, Montana, or Canada in the middle of winter, range numbers could look very different from what California-based tests show. And finally, competition is coming. Freightliner's E-Cascadia, Kenworth's T680E, Volvo's VNR Electric. These are serious products from companies with a century of trucking expertise. Tesla has the tech lead right now, but this race is not over. So here's where we land. The Tesla Semi is no longer a promise. It's a product. It's on roads. It's delivering real goods for real companies. And mass production means more are coming every single week. Is it going to replace every diesel truck on the road overnight? Is every challenge solved? Absolutely not. But the direction is clear, the momentum is real, and the companies writing billion-dollar checks to put these trucks on their fleets are not doing it on faith. They're doing it on data. Elon Musk said this would change freight forever. For the first time, there's enough evidence to say he might actually be right. If you found this video useful, hit that like button. It genuinely helps more people find this content. Subscribe if you want to stay ahead of the biggest shifts happening in technology and business. And drop a comment below. I want to know, do you think electric trucks are the future of freight, or is there something holding them back that we didn't cover today? I'll see you in the next one.